To be fair, humans can't really code either. I'm Ray Myers. Welcome to Craft vs. Cruft. We got a quick one today, a follow-up to my latest article on Mender.AI, which is LLMs Can't Code. And anytime I talk about the limitations of large language models, I do get people sort of rushing to the defense and saying, well, humans aren't perfect either, or, why do people have to denigrate their capabilities? I'm very clear and at other times that I think their capabilities are too powerful to be ignored. I do think that LLMs can be quite useful, but that doesn't mean they can do everything. And unfortunately, we have a lot of trouble having an intuitive understanding of what they can and cannot do. So that is the motivation here. If we're going to get the best out of them, we need to understand their limitations. And I think that there are very pressing limitations in the realm of coding. And coding is not one thing, as is explored in the article. We don't necessarily know all of the cognitive tasks that are involved in coding, but I think it is pretty easy to demonstrate that some of those LLMs are very good at and some of them are they're not. So the approach I am recommending is for us simply to divide the tasks and give to the LLMs the things LLMs are good at and use other tools for things that other tools are better at. So as a companion to the article, here's an example. Now let us try to use GPT-4 to refactor some pretty thorny code. Now in my previous article, Turbo Refactoring, I used an example from International Obfuscated C Code Contest, IOCCC, and that showed how actually a combination of LLMs doing very specific parts of the process with syntax transformations, doing the actual updating of the code, was quite effective and did things that LLMs alone do not do well. But that is a pathological example. This code actually was written by arguably the world champion of making obfuscated code. So, let's take something that is from at least the real world. A challenging example, but not a pathological one. Let's get a little more realistic. So this is from the TinyCC C Compiler, which is a pretty interesting C compiler. And, this is not the worst function I could find in here. It's not the easiest function. It's, just sort of a medium difficulty function from a fairly advanced code base. So this is the kind of example that I expect any tool suitable for legacy code to work on. The function is called decal designator. It's in tccgen.c. Now, let's be nice. Let's give it the comment as well, not just the definition of the function. So I've highlighted all. I'm going to paste this into ChatGPT with the GPT-4, so this is the premium version, and I'm going to select formerly known as Code Interpreter, the Advanced Data Analysis, even though I'm not going to be asking it to generate and run Python code, but everyone says that this version of the GPT-4 model is a little better at dealing with code, even when it's not using its code interpreter capabilities. So arguably the most advanced language model that exists. Let's see how it does and just refactor this code. Can you improve this C code? All right, so it's identified either because it was in the training set or just that it resembles things that this is part of a C compiler. It comes up with a lot of good sort of suggestions. I've had some experience with the refactoring suggestions this thing can provide, and they often are pretty reasonable. Not 100%, but these are likely to be reasonable suggestions. It's hard to say without zooming way out, but this is actually substantially shorter function than before, and it's saying that it's going to split out, other handler functions and such. So we want to be able to actually update the original. So let's just say great plan, provide the full listing. Okay, so we've got this handle array designator function, handle with cur field, all right? Get element size. I love these tiny little functions. So it's not exactly tiny, but it's much tinier. Good improvement. Handle multiple elements. And it says the decal designator is the same as it was. Okay, great. All right, excellent. So let's compile the updated version. And it doesn't compile. All right, so what has gone wrong here? Error, use of undeclared identifier P. All right, so on what? Line 7489 and 7442. So P is a local variable that was in the parent function and is not in the extracted one, and it should have been added as a parameter that would get passed in, but it did not. It did not happen. So let's correct that. So where do we need that? So that needs to be passed into handle array designator. All right, and it looks like it has it there. So what if I just add that as a parameter? And then there was another case. And so it looks like P needs to be passed in to this. All right, cool. So by changing 4 lines, I was able to get the output of this to at least compile. Is it logically correct, or has it broken the logic as well somehow? I find it is often the case that the refactored version has broken the logic as well, even after you resolve the compilation errors, but it's not really pertinent right now whether that's the case here. We could make sure it's under tests and run the tests and try and conform, or we could analyze the code. The point right now is that I think we're just barking up the wrong tree here. I don't trust something that is going to do an extract method and not be aware of which variables do and do not need to come along for the ride. I think that's just demonstrably not the right tool to be doing that operation, especially when we have a tool at our disposal that we were already in to do that, right? So it had good ideas here. The LLM produced some good actionable ideas. If you ask it to improve it further, it'd probably have some more good ideas. Not all of them good, but pretty good hit rate on this. I think that these were reasonable methods to extract. So why not just do that in a tool that knows how to do that, since we have one? So let me go to the old version of this. This was a case that got handled, whatever you want to call it. I think it called it something different, but we could extract method, handle no designator. So it instantly extracts that for us, and we can have a lot better confidence that it is doing something that isn't breaking the behavior, because it's performing syntax transformations by logic that has been reviewed and debugged. We want to do a rename. We want to rename C to something else. Like we can do that too. We don't have to be getting our code updates out of something with completely unpredictable behavior like an LLM. So basically the Mender.AI approach, if there is such a thing, to refactoring using LLMs is to give them control of these little menus. Let them make their edits in the safest way we know how. Don't just take their token output and copy paste it into production. So give that a think, see how it sits. And remember, as Lao Tzu said in the Tao Te Ching, With patience, the most tangled cord may be undone. Thank you.